IR, FTIR, spectroscopy, and all these things are basically based upon the finding of the chemical composition and chemical groups of these individual things. So groups you determine functional groups you determine in all these IR spectroscopy. What happens is you check the individual bond along with their transmittance and reflectance properties. You see in which range, in which wavelength range these things occur, and then you will characterize depending upon the bond कि कौन सा बॉन्ड आपको कितने वेवलेंथ पे मिल रहा है. तो यू कैन चेक कि आपका यहाँ पे फर्स्ट से आपको एमाइड लिंकेज है, एमाइड लिंकेज यू गेट. तो यू कैन प्रिडिक्ट अबाउट द नेचर ऑफ द फाइबर कि इट इज़ polyamide fiber or a polyester fiber, so on, depending upon all these things. So it detection of transition between energy levels in between the molecules which result from vibration of interatomic bonds. So we detect these transition elements depending upon their energy levels for a, and each frequency are shown to have a characteristics of particular functional group, because each and individual element have their frequency range or wavelength range for each molecule, and we determine all these things. So these are this is the electromagnetic radiation. If we say कि you can say कि this is the electromagnetic radiation. You say this is the visible region is between the 400 to 700 nanometers, and after this 400 to 700 nanometers, these are X-rays, gamma rays, cosmic rays, IR ray. In between them there are IR rays and other. You discuss about all these things, so you should remember these energy levels as well. This is far IR rays, mid IR rays. These are just for study purpose. And how you will determine this polymer analysis? So what happens is कि in the ground state, when you give energy, so they come to their next exciting state, because when an electron gains energy, it tries to move its orbit to the next spaces, next excited state. So it comes to the next excited state. During this state, the vibration of these individual molecules starts, and due to the vibrations they exhibit a particular frequency range, and we determine that frequency range, and depending upon the frequency range we determine the polymer analysis for these molecules, as say. So what happens is molecule vibrates and change in the molecule dipole moment, and due to this the change in the electron distribution around the bond, and the transition between the energy levels. Transition between energy levels means mu2 minus mu1, mu2 minus the energy difference we say about, because if you change the state, means one energy level to next energy level, the transition, the energy levels are changed, so their energies are changed, and the frequency also changes. So we determine based on these properties of the individual molecules. So if I talk about these UV rays, IR rays, they have all. Please mute yourself. So what happens is कि change in the electronic levels within the molecules, and changes in the vibration and rotational movement of the molecules. So these are used for the detection of functional groups. Functional groups are detected in these cases. So these are the types of structures that you see. many vibrations are in stretching. CH bond, if this it is present, to CH, so H stretches from here and carbon to H stretching from here. So these are stretched from two opposite directions, you say. So if a molecule is stretched from CH2, this is for CH2. So in case of CH2, stretching takes place. Stretching means one hydrogen is stretching carbon to upside and next one is to downside. Means what happens is कि these are symmetrical in structures. If these things are formed, these are not manual. These are all theoretical concepts, and based upon these things, energy levels are detected, and it is detected in an instrument known as FTIR. So all these things we say, if it is asymmetrical, this will come out to be like this. Rocking, wagging, these are all different types of stretching properties. So these things you should know for reference properties only, and these are vibrational modes for say, and some things are beyond our syllabus, and you should remember how these things are formed. This is the figure you should remember, important. Transmittance versus wavelength. So if you draw about this curve, about this transmittance, so you see these peak lines. So what is these peak lines? Each individual peak lines determines about the individual bond and energy levels. How you will know ki which bond is present in which? So you have to take the reference of the existing bonds. Means CH bond take place in between and around this region, wavelength region, wave number 1400 to around this region, and this CH is stretching symmetrical takes place about this region. So you have to take care of the reference for every each material. So these all are based out of a particular definite range of the things that I was discussing about. Huh. So this is the commonly found functional groups. CH bond is formed between 3000 per centimeter bending. C double bond C is here. C triple bond C is this. So each of the molecules have different these functional group, and it depends upon the bond strength is to mass ratio. So frequency is 1 upon 2 pi C under root K by mu. So K is bond strength and mu is the mass. If I talk about, so mass is the average mass. So m1 m2 upon m1 plus m2, basically it is inversely proportional, 1 upon m1 plus m1 upon m2. So m1 m2 m1 plus m2. So just for reference purpose, you should know this is important ki what is the wave number of these individual things. So if I talk about one more concepts about these absorbance and transmittance, we will discuss in the dyeing segment and chemical processing segment as well. But for understanding these absorbance and transmittance, these are measured by Beer-Lambert's law. Beer-Lambert's law says that if incident light and reflected light, if I tell about, then absorbance of any material or a liquid substance is equal to log I naught upon I2 is equal to epsilon CL. Epsilon is absorptivity coefficient, and T is transmittance. Transmittance is the opposite of reflectance properties. If I, the reflector means how much it is reflected, and transmittance is how much it is not reflected. It is a reciprocal of this reflectance. So absorbance of a sample at a particular frequency, I naught and I are the intensities of the light before and after interaction with the sample. So after that, after the reflection, I and I naught is before, it is original, and it is after. So it is determined by the ratio known as Beer-Lambert's law. Beer-Lambert's law is there in syllabus, and it is also important. So this is the kind of thing you can see. A is equal to log I naught upon IC. Epsilon is the molar absorptivity constant that would be given. सो इसमें भी आप यहाँ पे फंक्शनल ग्रुप का एनालिसिस इससे भी करते हो, जैसे यू कैन सी अबाउट द पीक्स, तो आप यू कैन डिटरमिन अबाउट कहाँ पे कौन से रीजन का पीक आ रहा है. तो इसमें व्हाट इज़ द एप्लीकेशन, तो एप्लीकेशन इज़ यूज्ड to identify certain groups in a molecule leading to determination of the chemical structure. So you can determine these chemical structures individually. So this is about these this thing.